All right, let's open the file on this. Think of this as a critical threat report. We're going to dive into some of the most common ways attackers hit our networks, and more importantly, how we can shut them down. Let's get started.
It's a pretty chilling thought, right? That an attacker can turn your own network against you. They don't always have to smash down the front door. Sometimes it's way more subtle. They just trick your systems into handing over the keys. So let's pull back the curtain and see exactly how they do it.
You got to understand that today's networks aren't peaceful places. They are constant battlegrounds. So in this briefing, we're going to dissect 3 critical threat vectors that every IT pro needs to know inside and out. We're talking about the brute force of a denial-of-service attack, the sneaky tricks of deception and interception, and finally, a really clever one called the replay attack.
Okay, first up on our threat list. This one's all about brute force. It's like a digital siege. Yeah, we're talking about the denial-of-service attack. And its goal, super simple, just take you offline. It's a direct assault on your network's availability.
A DOS attack really only has one goal: to make your services completely unavailable. The best way to think of it is like digital noise pollution. The attacker just floods a target with so much junk traffic that legitimate users, the people you actually want to serve, just can't get through. It's the digital version of 1,000 fake phone calls jamming up a company's switchboard all at once.
But here's where it gets really scary. How can a single attacker cause so much chaos? Well, they use a distributed denial-of-service attack, or a DDoS. And that isn't one person. It's a whole army. First, they build a botnet of these infected zombie computers. Then, those zombies go out and infect even more machines, growing the army. And finally, the botmaster gives one single command, and that entire massive network unleashes a tidal wave of traffic on one single unsuspecting victim.
And would you look at this? It's a whole chain of command. Right at the top, you've got the botmaster, the person pulling all the strings. They control these things called handlers, which are basically their command and control servers. And those handlers are what manage the botnet, the entire army of zombie machines. It's a surprisingly sophisticated and organized operation.
So how in the world do you fight back against a digital flood like that? Well, the key isn't to just pull the plug. It's all about filtering, and filtering smartly. We use tools like intrusion prevention systems and good firewalls to inspect and just drop all that malicious traffic. We also use anti-spoofing tech to validate where traffic is actually coming from. And we can use quality of service rules to basically tell our network, hey, prioritize the legitimate users and let the junk traffic wait. All right, so we've seen the brute force attack. Now let's switch gears completely. This next threat is way, way more subtle. It's not about overwhelming force. It's about lies and deceit. And it's how an attacker gets right in the middle of your private conversations to steal sensitive data. So how does this work? Well, on a local network, devices use a protocol called ARP to figure out who's who. ARP spoofing is essentially identity theft, but at the network level. The attacker's computer basically just shouts, hey everyone, I'm the gateway to the internet, and sends out these fake messages to trick all the other devices into sending their traffic directly to them instead of the real router. This here lays it out perfectly. Look at the difference. Normally, your computer asks, who's the gateway? And the real gateway responds. Simple. But in a spoofing attack, the attacker's machine is set up to reply faster and louder, poisoning your computer's internal address book with its own address. And from that point on, your computer, without knowing any better, sends all its data straight to the attacker. And that right there, that's the whole point. The ARP spoofing is just the tool. The prize is the man-in-the-middle position. By tricking both you and the real gateway, the attacker places themselves squarely in the middle of your communications. They become this invisible eavesdropper, able to read, modify, or even inject anything they want into your data stream. Pretty scary. The defense here really comes down to not blindly trusting announcements on your network. Thankfully, modern switches have some smart security features for this. First, DHCP snooping builds a trusted database of legitimate device pairings. Then you turn on something called Dynamic ARP Inspection, or DAI, which acts like a bouncer. It uses that trusted database to check every single ARP reply, and if one comes in that's fraudulent, it's instantly dropped. All right, our final threat vector is a sneaky one. It's not about overwhelming you or deceiving you in real time. Nope, this one's about capturing a valid transmission and just using it again later for malicious purposes. This is the replay attack. Imagine an attacker records you using your keycard to open a secure door. A replay attack is the digital version of that exact thing. They capture your valid login credentials or authentication packets as they're traveling across the network. Then, later, they simply replay that captured data to the server. The server sees what it thinks is a valid session, and it just grants the attacker access.
So how do you stop that? It sounds really tricky, but the solution is actually beautifully simple. How do you stop someone from replaying an old message? You make sure every single message is unique so it can only be used one time. It all comes down to a sequence number.
And this shows you exactly where that defense lives. Inside secure network protocols like IPsec, there's this specific field called the sequence number. It's just a simple counter that goes up by 1 with every single packet that's sent. The receiving device keeps track of these numbers, so if it ever receives a packet with a sequence number it has already seen, it knows right away that it's a replay, and it just discards it. The attack is stopped dead.
Phew. Okay, we've covered a lot of ground on the digital battlefield today. So now it's time for the debrief. Let's consolidate our defensive postures and review the key countermeasures for each threat we've analyzed.
Let's lock in these key takeaways. Against the brute force of a DDoS, we deploy intelligent traffic policing and strong firewalls. To counter the deception of spoofing and man-in-the-middle attacks, we harden our switches with DHCP snooping and DAI. And to defeat the sneaky replay attack, we enforce secure protocols that use those incrementing sequence numbers, making any old captured data completely useless. So we've armed you with the intel to neutralize these common threats. But the digital battlefield is always evolving. The question you should leave here with is this. Now that you're prepared for today, what's your strategy for the threats you haven't even seen yet?